All right. Thank you for the invitation to speak at this meeting. And I guess I'm going to start a little bit with an overview just on manure management and water quality. And I'm from Ontario, Canada, and although we're a different country, farming practices I've discovered aren't really that different. And probably the biggest difference between Ontario and Ohio is maybe the size of the biggest operations, and that most of our manure storages are not lagoons. We probably have more cement storages than we do lagoons. So kind of as an overview, I'm going to look at how water quality and manure are related, water quality and soil health are related, and then look at some of the practices that go into the planning of manure management so that it's not just the tank's full, we've got to get rid of the manure, where are we going to put it? Instead, looking at a way of planning for manure application all through the year and looking at opportunities and maybe looking at some changes in crop rotation to take advantage of some of those potential opportunities. So nutrient management and 4R practices, and for those of you that aren't familiar with 4R, it's the right rate, right source, right place, and right time. Probably not in that order, but it's basically the same thing as nutrient management. And so I guess if we look at doing those kind of practices, that will be the biggest method of preventing contamination of water sources. And so to prevent those nutrients from contaminating water sources, I think soil health is a really important part of having good water quality. The practice of putting on manure or organic amendments in combination with cover crops, having a good crop rotation and taking advantage of the timing of some of those crops in the rotation, but also as a way of improving that soil health so that at the same time we're improving infiltration and water holding capacity and nutrient cycling and all those good things that the soil do for us. And then also part of it is knowing the value of manure. And I'm not going to spend a lot of time on analysis, but if we don't take an analysis and we don't know what the nutrient content of the manure is, it's really hard to value that manure. So in Ontario, our soil quality has decreased over the years. And from the labs, we got some records of soil samples that included organic matter that were taken from 2002 to 2018. And so this blue line is all Ontario. So it's something like 40,000 samples. Oops, I didn't mean to do that. And it shows the decline in soil organic matter over that 15, 16-year period. And then I took the 3 counties that are probably the highest, or probably the most similar to Ohio in both topography and soil type. They tend to be a heavy clay soil, and they tend to be fairly flat. They tend to have very little livestock, but a lot of corn, soybeans, and especially soybeans in the rotation. And so over that same period of time, you can see the decline in that soil organic matter. And it's about 0.75%, which is a huge decrease in water holding capacity and in just soil carbon. So soil quality is directly related to the water quality. If we've got decreasing organic matter and we've got a decrease in diverse rotations, so in other words, a lot of corn, soybean, or soybean rotations, we've got an increase in field size and equipment size, we've got increased soil compaction. All of those together increase the amount of soil erosion that we have, increase the amount of nutrient runoff, also increase the amount of compaction and decrease water infiltration. And in Ontario, we've got over 75% of the row crop fields would have tile drainage. And in recent years, that tile drainage has mostly been putting new tile in between the old tile. So if 40 feet spacing wasn't enough, now it's starting to be more like 20 feet spacing. So it's obviously a problem in that infiltration, and if we've got poor infiltration and compacted soils, then we've got a higher risk of reduced water quality. This is just a couple of pictures that show soil and nutrient movement in the part of Ontario that I live in. This bottom picture, it's a field that had a lot of residue, a lot of corn residue. We had a 2-inch storm go through, and that was the residue after the storm. This is pictures taken just recently, actually not this year, but I've got some that were taken just yesterday. Manure applied in the winter. I don't know if that's a problem in Ohio. It shouldn't be a problem here after the nice weather we had over the past year and the opportunities we had for manure application. But yet every year there's farms that apply some manure in the winter. And this is a big problem because most in Ontario, and I'm assuming the same in Ohio, most of the phosphorus loss and nitrogen loss too occurs over the non-growing season period. So there's an increased risk for phosphorus loss from November to April in Ontario. There's often a lot of intense rainfall during this period when there's very little protection in the soil from crops or from canopy or even from residue in a lot of cases. And so in the past couple of years where they've done the monitoring, over 80% of that phosphorus loss is occurring during that period of time. And you'll see in this graph that nitrate is, we don't talk about it as much, but nitrate loss is also pretty big in the non-growing season. And in 3 different watersheds in Ontario, it shows they've done the studies on how much total phosphorus is lost and how much is lost from runoff versus from tile. And the surface is the dark blue, the tile is the light blue. And it really depends on what is the topography. So if you've got the area that's most like Ohio where it's flat, heavy clay soils, we've got a lot that's going through tile and surface application, or surface runoff, I mean. But in these 2 watersheds, you've got a lot more topography. So there's more that's in surface runoff and less that goes through the tile. You can see that the standards in Ontario for surface water quality for phosphorus is 30 parts per billion or 0.03 milligrams per liter. And you can see that it doesn't matter what watershed we're in, we've exceeded that for total phosphorus, and even for dissolved phosphorus in some of those cases. And this is just, this comes from our nutrient management, best management practices, but we look at loading limits, and we look at loading limits during the whole year. And the way that loading limits are determined are by looking at what is the slope in a field, and the slope especially close to the water course, and then what is the infiltration or the drainage class or the hydrologic soil group. And depending on if it's a sand, which would be rapid, or if it's a heavy clay, that impacts what the runoff potential will be. And then once we've got that runoff potential, then we look at what is the runoff potential, is it being incorporated right away or surface applied, and that gives an indication of what is the maximum application rate before you can start to see some runoff. And the point that I thought I would make with this slide is if we've got frozen conditions, then it doesn't really matter what our drainage class or hydrologic soil group is. Every soil, if there's no infiltration, would be in a high runoff potential. And a high runoff potential is basically equal to 5 millimeters of rain or in imperial 0.2 inches of rain. So it's not a lot of application or solid manure even with rainfall afterwards to start moving some of those nutrients. This picture, this was one that was taken yesterday of application, and hopefully we don't see a lot of that this year. The other one that's big in Ontario, because we've got so much tile drainage, is preferential flow. This picture at the top is a study that we did where we intercepted tiles and we did different forms of application. And in the worst case scenario where it was injected without breaking the macropore ahead of it, it took 7 minutes for the manure to get into that tile drain. And what's happening is if we've got earthworm channels or root channels, and if we've pre-tilled or broken that macropore so that it's not a direct connection to the surface like it is in this one, then if we apply manure, if we've done that pre-tillage, we don't have that same risk of that manure getting to the tile drain through preferential flow. And that's a big one in Ontario. That's every year we get issues with preferential flow. So that's the issue. How can we do manure management so that we protect our water sources by applying those nutrients at the right time, in the right place, and at the right rate? And so one of the questions is, if can for our nutrient management fit into manure management? And of course, the answer is yes. But some of the questions that we need to ask, especially for those livestock operations, is how much manure is produced, how much storage is available. And for Ontario, the minimum is 240 days, basically to cover the winter period. How many acres will the manure be applied to? Because you can have all the land base you want, but if it's only applied to the 50 acres closest to the barn, that's not really a solution. What is the crop rotation? And where are the opportunities in that crop rotation to apply manure at a time when you've got good growing season conditions, or at least not winter conditions? And then what is the timing of that application? And so at the end of the day, if we do better planning, it means we'll find more opportunities to apply manure more often during the cropping season. So most fields with a nutrient management plan, assuming that they're not extremely high in soil fertility level, are still going to need some commercial fertilizer. If we apply manure for phosphorus to a corn crop, we aren't going to have enough nitrogen, so there will still be some commercial nitrogen required. The other thing, most nutrient management consultants don't share the information with retail, so there's a disconnect between the retail and the farm in what nutrients are already being applied through manure. So I think there could be a bigger role for our retail in collaborating with nutrient management consultants or farms that have nutrient management plans, so that livestock manure plays a bigger part in that planning process. For our retail can provide additional services to livestock farms that can improve manure management, and some of that's in the record keeping, and some of it's in just asking some of the questions and having access to some of the information that might not be readily available, mapping, that kind of thing. And for Ontario, at least, all farms, if they were being under that 4R nutrient management, if all farms were treated the same and had the same rules, I think it would mean better understanding, better idea of what's allowed and what's not allowed, and probably improve the water quality across the province. And it also means positive messaging for sustainability platforms. And so I'm not going to spend any time on these slides, except to say that in that 4R certification standards, where they're doing the audits, they've figured in for the application standards how to work in some of the factors that are already in place for the nutrient management regulations and standards. And so one of them is the phosphorus assessment. So for example, if application has to be done through surface application, then the 4R audits need to know that phosphorus loss isn't a high risk. And so there's a phosphorus risk assessment tool. And in our nutrient management software, we have just put in a phosphorus loss assessment tool for Ontario. It's like a phosphorus index, and it takes into account erosion, soil test, crop type, hydrologic soil group, or drainage class, basically. Some of the BMPs that are happening, local precipitation, is there tiling? What is the average tile spacing? What is the application method? What is the application timing? What is the application rate? And those all get to put together to give us a Plato index. And that Plato index, instead of giving a number that's associated with a risk, it's been put into a color code. And in the nutrient management, that color code comes up automatically, so that if somebody sees it's red, they can go and look at where there's some opportunities for improvement. The phosphorus index is broken up into two components. One is the field characteristic, or the inherent index, things that you can't really change, like slope or like soil type, soil texture. And then the other one is all based on application, either from fertilizer or from manure. So we look at, for the field characteristics or the inherent phosphorus loss, particulate from the surface, particulate from the subsurface or from the tile, dissolved from the surface, and dissolved phosphorus from tile. And then we do the same thing for the application, for the manure or for the fertilizer. Those get put together to give a total phosphorus loss assessment. And so that's part of our nutrient management software that's available to farms. And then the record keeping is another one. Record keeping where manure is included. The analysis is an important part of it. Setbacks to sensitive areas or to water sources. Sensitive areas are documented, so not just the nutrient recommendations, but it's also mapped. And then all nutrients are accounted for, including the nitrogen credits from legumes, manure, biosolids, organic amendments, whatever. So I mentioned that we have software in Ontario, and this software, it's based on Ontario recommendations, but there's aspects of it that would probably work for anybody. It's available for phone, tablet, computer, English, French, sorry, no Spanish, metric, imperial, and US gallons. So it includes the crop nutrient calculator, which basically just looks at NPK needs and crop nutrient removal based on location, soil test, previous cropping yield. The organic amendment calculator or the manure calculator looks at available NPK and economic value, and then the micronutrients that are applied if they're included in the test numbers from manure or from organic amendments. Fertilizer just gives, you can blend fertilizer sources to achieve target fertilizer rates. The Plato, it's just looking at the different phosphorus management risk losses or losses based on management practices. And then all of these get combined that you can do a field management plan so that you can put all of it together. And so that's something that's new for our farmers. The consultants use that software in a more complicated form. We've tried to put it together in simple tools so that farmers can use them and can access them pretty easily. So all of this, putting it all together, how do we on the farm look at preventing nitrogen and phosphorus loss using those 4R management standards? And year-round planning, I've already mentioned. Where can manure fit into the management on my farm? Can I maximize the crop rotation for manure application opportunities? So looking at things, at least in Ontario, at spring application on wheat fields, especially the fields that are flat that don't have a lot of water movement. Application into growing crops, so into corn, onto forages after each cut potentially, or pastures after the animals go off. This is the biggest one in our area after wheat harvest with cover crops. A lot of livestock farms have wheat in the rotation specifically so that they can have an opportunity for manure management. And then on dairy farms after corn silage and often with a cover crop. This is information that was presented in Ontario by Scott Shear a couple of years ago. And I found it extremely interesting because if we do application in the non-growing season, often when the weather conditions are poor, soil conditions are wet, we get a lot of compaction. And Scott presented some information that looked at what percentage of the area is trafficked. And then in those, if you've got in this example, 45% of the area that has wheel traffic on it because of manure application, and you get a 6 bushel yield difference where you've got normal field conditions versus trafficked area, or you've got wet conditions where you've got a 27 bushel loss, then 27 bushel loss on 45% of the field gives you a pretty big economic incentive for applying at a different season. So if you have wheat in the rotation, the opportunity for cover crops and manure at a time when you're not causing that compaction, then that goes a long way in paying for having a crop that maybe doesn't yield as high or doesn't give as high an economic return. So there's more than just economic return in looking at management of different crops in the rotation. The other one, and this is not related to crop rotation so much, but it's valuing the resource. So we've got manure in the storage, and I'm using this example of a finisher hog manure, 1 year open pit, and approximately 1.13 million imperial gallons, or 1.5 million gallons US. So at capacity, based on just regular manure analysis or average manure analysis, I've got an awful lot of nitrogen. So if I use that as a source as urea, and then the phosphorus and as MAP, and then potash, I've got in that storage about $71,000 of crop available NPK plus micronutrients and organic matter, which isn't accounted for in this number. So it's a huge amount. And so the question is, how would these nutrients be managed if they were purchased at ag retail, if they weren't manure? And do all the fields that these nutrients are being applied to actually need the nutrients? And I'm going to come back to that one in a few minutes. The other one, same type of storage, but how long would it take to pay for covered storage? If we took the rainfall out of that storage, we could save about $4,000 a year just by having a more concentrated nitrogen, not having to transport the water, because it's expensive to transport water if you've got a manure that's at 1% or 2% or 3% dry matter. You're spending a lot of time spreading water to the field. So can we look for opportunities where we cover storages? And that might be harder for lagoons than it is for some of the concrete storages. But on a per year basis, looking at how many days of storage, if you covered it, you would have 500 days instead of just a year. Your nutrients are more concentrated, and so you're saving money on a couple of different fronts. So just looking at, is there a way that we can reduce the amount of water that we're transporting to the field? In our area, there's some interest in liquid solid separation, separating out, especially in dairy manure. If you've got something that's at the 8% dry matter, can you use a screw press or some type of a separation system so that you get the solids at 60% plus? And then if you've got high fertility levels, it also makes it easier to broker that manure to a neighboring crop farm, and it maximizes the economics of the storage. And then the liquids that are remaining can be applied to fields during the summer, either through some type of, I guess irrigation is not an option, but to forage fields or fields that need the water that time of year. Manure on wheat, we did some studies, and with dairy manure and with most of the manures that have a higher carbon to nitrogen ratio, the recommendation 2/3 manure, 1/3 fertilizer. We did see a big difference, not big difference, but we did see a difference in the protein. Where we applied manure, we had higher protein. And if we had pig manure, tended to work better than a dairy manure that had a 8% dry matter. The lower the dry matter, the better the results, but also the higher the application rate. Right time, right place. Glenn's going to talk about that, so I'm not going to cover that. Manure on forages, that's a big one in Ontario. I think almost every dairy farm applies, or most dairy farms apply manure after at least one of the cuts. In the area I live in, there's often 3 or 4 cuts of forage. So if the weather conditions aren't right after first cut, we get a rain or whatever, then there's the opportunity to go in after second cut or third cut. And sometimes farmers will go in after they do a haylage cut as opposed to a hay cut, just because the hay is down a little bit longer. They can't get back to the field quite as quickly. So why apply manure to forages? Application timing is a big one. Nutrients to growing crops is beneficial. Those crops can use the nutrients, so it prevents the environmental losses. It applies the phosphorus and potash specifically that the crop has removed. And I don't think farmers realize in Ontario at least how much potash is removed from a forage crop. If we're not careful, we don't apply the potash, we can lose up to 35 parts per million of potash just in one rotation from alfalfa. We can save on commercial fertilizer dollars. It reduces the storage requirements if we can empty that storage in the summer, spreads out the workload, reduces compaction, and it gives about a 10 to 15% yield and quality increase. And that's something that we did some studies on over a number of years, and saw that there was an increase in quality if we put the yield and the quality information into the milk program, there was a pretty big difference in how much milk would be produced on those forages. The ideal application rate between 3,000 and 4,000 gallons. Basically, you don't want to apply more than 50 pounds of nitrogen in ammonium form. And it also provides sulfur, which in our area is becoming a bigger and bigger issue. And it's always a good idea to have an analysis at the time of application so that you know what kind of a credit you can expect. The key with manure application on forages is to try and get to the field before you get any kind of regrowth, because if you've got regrowth, you're damaging the crowns and you've got new regrowth that has to happen at the crown. We did some ammonia loss measurements on forages for several years and looked at the difference between shallow injection versus surface application. And what we noticed consistently is that the biggest application or the biggest nitrogen loss is right at the beginning. The higher the pH of the manure, the quicker that loss. And the higher the application rate, if there was any kind of ponding on the field, that would be where the application losses were the highest. And what we did is we took dosimeter tubes, we put them under pails. The pails had holes in them, and we would go in and look at those dosimeter tube readings every day, or sometimes at the beginning twice a day, just to get an idea. Manure and cover crops. I know that Melissa's going to talk about this, so I'm not going to spend much time on it. But some of the questions in Ontario with cover crops is which cover crops work best with manure. Oilseed radish is one, oats is one that have been really good in Ontario so far. Manure, another question, manure ahead of the cover crops, or do you apply the manure after the cover crop has started to grow? And then the other one, how can we seed the cover crop and do the manure application in one pass? Slurry seeding is one option. People have been trying air seeders or other kinds of methods to try and get that seed mixed into the profile, but not too deep with cover crop planting and manure application. Another one that's being tried in Ontario, strip till. So after soybeans come off or after corn comes off, if it's early enough, some farms will go in and they will do a strip, put the manure into that strip, or they'll put cover crops in that strip. And then the opportunity to plant into that strip in the spring. It's still new. There's not a lot of people doing it yet, but there's a lot of interest. And as soon as farmers start thinking about that they want to do a practice, they'll figure out a way to make it happen. The synergy is the part that I'm really interested in. This is on the left side, cover crops with no manure. On this side, cover crops that did have manure. And you'll notice that there's a lot more roots, there's a lot more biomass. And this is the field that those cover crops came in. You can see, it's pretty easy to see where the manure was applied versus where there was no manure. Huge difference in that biomass. And we basically, where we had oats or where we had the mixtures, we had about 2/3 difference, or not 2/3. We had 33% increase in the biomass. What we found out though is that if you've got manure being applied, it's probably not economical to have a whole bunch of different species, because you're going to get the few species that are dominant and that are going to grow and probably shade out some of those other species. So far, that's been our observation. And then one that I really wanted to just spend a minute on, we did for several years in a row, oats by itself and oats with anaerobic digestate, dairy from a dairy farm. And we did a lot of sampling. So we had, just with the oat cover crop, just over 2.5 tons per acre. With the cover crops and the organic matter, almost 4.5 tons per acre. When we put that into the milk, the Wisconsin milk program, we did have more milk production. And so what I think is kind of cool here is a lot of people will say, yeah, cover crops, that it just costs me money. But in this case, if you've got a crop that you can harvest afterwards and you've still got the roots that are adding to the organic matter and you're preventing nutrients from moving off the field into the environment, and we're increasing the amount of milk production, then it makes it an economic advantage to have those cover crops in that rotation. And then the other thing that I thought is, if you've got this much feed value for cattle, what is that feed value for the microorganisms in the soil if you return all that carbon back to the soil? Then the other thing that we did is we did take the quality measurements. And so looking at it in a different way, if we only applied digestate to, no, I guess the question that we were looking at is, how long would it take with each of these practices to increase my soil organic matter by 1%? And so if I did only digestate, it would take about 200 applications to increase the soil organic matter by 1%. If I did only cover crop oats, it would take about 26 crops to increase the organic matter by 1%. If I have the cover crops and the digestate, then it's about 15 times to increase organic matter by 1%. So there is that synergy in combining cover crops and feeding those cover crops and feeding the microorganisms in the soil. It's just a cool way to look at cover crops from a little bit more economic perspective. The other one that I just wanted to spend a bit of time on is selling manure. We've got in our area some areas where there's a lot of livestock farms, so there's not a lot of cash crop neighbors really close by, or neighbors where you can take manure to. But in every area, you've got cash crop farms without livestock. If I've got fields that have really high fertility levels versus fields with low fertility levels, and I apply swine manure, let's say finisher manure because I like the numbers. If I apply the NPK, then because my phosphorus and my potash are already so high, it's going to take years and years before that phosphorus is contributing to any nutrient value for the crop. So it's really only the nitrogen and maybe a little bit of the phosphorus or potash that's contributing to any economic value. Where if I've got a field that needs those nutrients and have a relatively low soil test, then I'm making use of the full nitrogen, phosphorus, and potassium. I'm getting much more value for those manure nutrients. And so if I sell manure to a cash crop farm, then I see those dollars immediately instead of waiting 10, 20, 30 years for the soil fertility levels to go down so that they actually need the nutrients. Some people will sell manure to neighbors. Some people will trade land where they'll grow corn for a neighbor or hay for a neighbor, and then put manure on their farm. So there's different ways to do this, but it's a way of distributing the manure so that you're not contributing to higher soil test levels and higher potential losses to the environment. And basically this is saying the same thing. It's moving manure from areas of high fertility to low fertility, looking at some I guess regulations or methods through municipalities that make it easier to do that. So for example, instead of transporting on the road, is the opportunity to have some pipelines that go to the center of a block and then be able to drag hose or tanker from that spot. So there's different things that are being considered and looked at. So in summary, manure and organic matters provide nutrients. They they provide soil organic matter, and so value to improving the soil. A 4R approach, right time, right place, right rate, and right source are going to provide the most economical nutrient utilization and minimize the environmental risk of contamination. That 4R approach with application to growing crops during the growing season is also going to prevent nutrient loss to water sources. And I guess the other thing to keep in mind, maximum value doesn't always mean maximum nutrients. Sometimes there's a compromise to nitrogen or to full utilization of every nutrient in exchange for labor or soil quality or other farm priorities. That priorities on some of the farms result in different management practices, and really that no farms are exactly the same. So that's a really quick overview. But if anybody has any questions.